Hey and welcome back to a new video. Today we'll look again at crazy technologies and questionable items that did not make it to the market, that were basically dead on arrival. Last time we featured Seasonic Connect and, for example, Intel VRock, and today again we will have an amazing technology or concept by Intel. The Seasonic Prime PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comms included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. And to be more specific, we were not talking about an Intel product this time, but about a concept or a service that Intel tried to offer from 2010. Back then they were like, okay, hiding features behind a paywall, that is a super nice idea that we see a lot in software, and we are also trying to do the same thing with CPUs. They were trying to establish CPU DLCs, and that was called the Intel Upgrade Service. The idea behind it was rather simple. Intel would sell you a CPU that had features on it that were simply locked. And if you would decide later on, maybe a year or 2 years after purchase, you would need more performance, you could unlock this with Intel's upgrade service. At that time, Intel's Socket 1156 was basically state of the art with, for example, P55 chipsets, where you could use CPUs like the i5 750 or the i7 875K, which was one of the first K CPUs. And if you're thinking, hey, maybe it was one of those CPUs, no, it was not. It was pretty odd because they started this with one of these Pentium CPUs. The CPU we're talking about is the Pentium G6951. And back in those days, Intel was using the Pentium naming much more commonly, and this was targeted towards like office use or low power computing. And this G6951 was using 2 cores and 2 threads and a clock of 2.8 GHz, and it cost at the launch time about $90 US. With 2 cores and 2 threads, it means that this CPU came with hyperthreading disabled at the time of purchase, and that is where Intel's upgrade service came in. So you could buy one of these Intel upgrade cards with a code on the backside. You could then use this code inside a very specific Intel software to unlock hyperthreading and also extra level 3 cache. And it took me a lot of time to dig into the internet, but I was able to find this software even today. And I will set up the system and we will take a look if we can even install this still today. And here we have it, 16 years old. Let's see what happens. Intel upgrade application. And here we can see the setup version. So this is how it looked like. It also tells us that we will need a key and a restart will be required. It is currently checking for compatibility, which we obviously don't have at this point because this is a much newer system. But I just wanted to see if this even still works and what it looked like back then. It is telling me that it's unable to connect to the internet, and that's not really true. I mean, my system has internet, but I guess the servers from back then just simply don't exist anymore, which means that even if we would have the hardware today, we would probably not be able to install this. This is sad. I would have loved to upgrade my G6951 to hyperthreading today, which is unfortunately not possible anymore. But even back then, it didn't really make a lot of sense. If you bought the CPU for $90 and you got the upgrade card for $50, you paid $140 in result. And already back then, for example, you had an i3 530 that was just much cheaper and at the same time even faster. So that just altogether didn't make any sense. And even in 2010 it was not that easy to perform this upgrade because it was not only limited to the CPU but also to the compatible mainboard. And it was by Intel limited towards specific Intel motherboards. So all of this was quite complicated, but it didn't stop Intel to try the same thing in 2011. Again with an obscure CPU selection of the i3 2102 and also again an Intel Pentium G622. And while 500 to 600 MHz might sound much, it didn't help as much because both CPUs were pretty slow from the start. And there was the same issue as before. If you bought the Intel upgrade card, it just made your entire setup pretty expensive but still pretty slow. And just buying a faster CPU directly like an i5 2400 made a lot more sense. End of 2011, Intel decided to kill the upgrade service, which was not quite so. End of 2011, Intel tried. End of 2011, Intel decided to kill the upgrade service, which was kind of expected because it was doomed from the start, at least in my opinion. It started with a pretty questionable CPU selection, CPUs that were not that common and were not great from the start. Then you were limited by a specific mainboard model, and it also cost much more than just buying a better CPU from the start. All of this together led to that Intel decided just about 1 year later after start that they have to kill the upgrade service. The next topic is a standard, which is related to this cable, a SATA cable. You surely know that you can use these days to connect, for example, cheaper SSDs with your motherboard. In 2014, which is 12 years ago, it wasn't about a simple SATA cable. It was a time when newer and faster SSDs came into the market, and this standard was about to become a bottleneck. With about 560 megabytes per second, this was the state of the art that was possible, but we knew that something had to be done. That's why the industry decided to go with SATA Express. Not to confuse with eSATA. That is something we will save for another video. And I can remember in 2014 going to Computex, and I basically saw every C97 board with SATA Express equipped. And while this is not a C97 motherboard, we can still use it to take a look at a SATA Express connector, which you can see right here. And the interesting part about this is that this is combining two technologies. We can first see two normal SATA ports on the right, and then you can see a smaller connector on the left, which is to control the port. And this one is basically combining two technologies. So it's not only two SATA connectors, but these two SATA connectors also carry two PCI Express lanes. And that's where the name comes from, SATA Express. It's combining two technologies in one connector, SATA and Express, PCI Express. We have two SATA 6G connectors and PCI Express lanes, 2 lanes. And even back at the time, they were talking about PCIe 3.0 lanes, but that was just a theory, because at the time, C97 was launched. And those C97 chipsets, they could only carry or connect PCIe 2.0, which was much slower. And that's where also, for me personally, a misconception came from, because when I saw this the first time, I was like, hey, this is quite cool. This should be quite fast, right? So we have two SATA ports and PCI Express lanes in addition. This should be fast, but it's not an AND technology, it's an OR technology. And with this cable or port, back at the time, you could have a transfer speed of about 1000 megabytes per second, at least in theory. And that was not caused by having two SATA ports, but just by PCI Express. And that's what I meant with a technology where people had to decide what they want to actually use. Because while it supports SATA and PCI Express, you couldn't use both at the same time. You could either use two SATA devices or a PCI Express SSD. And they made this cable at a time where they knew SATA is super common, but they wanted to make it easier for the user to also support PCI Express SSDs for the future. They were right that PCI Express was the future for SSDs, but simply not with this cable. And that was also quite interesting at the time, at the Computex 2014. Basically every motherboard was equipped with this connector, but you could hardly find any devices. Western Digital was showing an HDD SATA Express prototype, but this one never made it to the market. ASUS was showing a SATA Express SSD, but this was more like an adapter rather than a real SSD. And also this one was not really making it to the market either. And the only thing I could find that actually made it to the market is ASUS Hyper Express, this one. Thanks to Nori for buying this for me in the US and sending this over. But this was also not an SSD or an HDD, it was also more like an adapter. And that's also where the SATA Express cable is from, that I already showed a couple of times in this video. And I can tell you it is so difficult to find a SATA Express cable these days. Even back then, they didn't really exist because there just weren't any devices for it. And this is what ASUS Hyper Express looked like. Small metal frame, and it would fit into a 3.5-inch bay. The connector reminds me of a U.2 connector. So you would connect this SATA Express connector with your motherboard, and then on the other side connect this one to the ASUS Hyper Express, and also add SATA power to it. And inside we have an SSD adapter. I'm pretty sure you know this connector right here. So that is a simple M.2 connector. And the one on the left was common quite a while ago. It's not that common anymore. That's an M-SATA connector for this type of M-SATA SSD. And when you're reading a bit of the backside information, you will understand that they're dividing this into what they call lane 1 and lane 2. And then you can decide how you utilize these spaces. So lane 1 and lane 2. And you can either decide to run this with two M-SATA SSDs, like this one, or two normal and today common M.2 SSDs. And there's also an S-Media controller right here, which supports RAID 0. And then by pressing this connector right here, you could set the device into super speed mode and thus run RAID 0 across the two SSDs that were installed. Or just run the normal operation and access two normal SSDs individually. But again, also with the ASUS HyperExpress, you had to decide if you want to run either mSATA or also run with PCIe M.2 SSDs. And ASUS was advertising that this can run speeds of 10 gigabit per second, so that's about 1,200 megabyte per second. But when the thing was tested, it could only perform up to about 900 megabyte per second, which was still much faster than at the time common SATA 6G standards. One factor that killed SATA Express was the time when it came to the market, because at that time, M.2 NVMe SSDs were already common in notebooks. And they had the advantage of carrying twice as many PCI Express lanes than this cable. They were smaller and easier to use, where this cable just didn't look really appealing for cable management, for example. Like even the older normal SATA cable was better than this one. The nail in the coffin, however, was the fact that there were simply no SATA Express devices available for purchase. The only thing that was available is this thing here, the HyperExpress, which was rather special and not really an SSD, right? It's an enclosure, it's an adapter, but that's basically it. So the reason why it didn't make it to the market mainly was it was too slow for the market. The market already decided that it wants to go for M.2, and it was just not nice, not good to use. I hope you enjoyed this video. First off, with an Intel technology that was just to drain the customer and it didn't work, and this one that was just simply too slow for the market. I hope you enjoyed this. See you next time. Bye bye.